Hi, my name is Chris Campbell. I'm head of hardware and developer relations here at Golioth. And the thing I have to keep reminding myself is no matter how many times I've seen the Golioth console and all the things it can do, I need to keep showing everybody. And that's what we're going to be doing here today. So we're going to be looking at a mini fleet of 4 Thingy 91s. Those have an NRF 9160, which is a cellular processor plus modem on board, as well as an NRF 52840. We've been using that for some interesting stuff lately, but we're not going to be showing that here today. So instead, let's just take a look at this. Here is my little device that's actually a little, it's kind of off camera. Well, it's a camera here. We're going to be showing these 4 devices. They are all organized as north, south, west, and east. I guess I kind of said that weird, but those are how we've labeled them here. And we're also going to show you here on the console. All of these are running our example firmware. It's actually all downloadable. It is all linked down below. So if you had a Thingy 91 and you wanted to go, or a Thingy 91X, you could actually go and use that firmware, install the binary that we actually have as a released version, push that onto your Thingy 91, put in credentials from the Golioth console, which I'll show you here in a second, and you would have all the same functionality. So if you want to do that, you can go do that down below. Or keep watching, I'm about to show you how it works. All right, let's take a look at this and see how all these things work together. So we still have our things up here. This is the Golioth console. If you've never seen it before, this is a project that I created in the Golioth DevRel organization in the Golioth, the Thingy 91 fleet project. That's what it's called here. And you see that I have 4 devices with one disabled here. Each of these are labeled with some tags over here and with names. And I realize now I should have made this a little bigger. Let's do that. There we go. And so each of these is labeled. So let's first talk about all of the things that we can do, but I guess maybe one of the most interesting, especially seeing kind of 4 at once, is that these are all running the same firmware. They're all talking to the cloud, and they all look a little bit different here. And that's actually because they all have a device setting. So this is a capability on the Golioth Cloud where you go from the cloud to the devices. So let's go into the device settings, see what's actually available here. You see that these are all bespoke, so I created these along with my coworker Mike, and these are just basically variables that we're using from the cloud down to the device. And in order to kind of showcase what this, how different these all are and seeing them kind of get all the updates at once, let's go and turn off this blue LED here. You see that we have a confirmation message here. I'm going to say confirm, and we should see these all change. There we go. And so all of these are changed now. Oh, maybe that bottom one hasn't changed actually. We can go in and see whether or not the bottom one has changed. So let's go and look at the south here. I'm guessing I actually know what happened here. If we go into the settings menu, we could see that I went and I overrode that one specifically on the blue intensity. So if I want to also turn that one off, I can just go and delete this, set it back to the default status there, and so now it's only the red ones on there. Or if I want to, I can go and individually control each device here. So I can go turn that back on, and you see now it's red and blue back together. That gives us that purpley kind of color. Over here, this is red and green is on, this one's red's only on, and this one has none on. Similarly, we could go and turn each of those on individually by going into the device record. Let's go back to the devices though. So if we go back to the device list here, you see the 4 devices, you see the session was established, you see the last report. These things are checking in every about 30 seconds. That is also configurable using Golioth settings. So let's go and look at this one that's actually turned off right here. First off, let's make sure it's the right one that we're doing here. So we can just make this one, well, let's make this just pure green. So we'll go and turn this on to pure green, and that should turn on. There we go. So now we see that that's on. You can see that these things are also flashing, and each time it flashes, that's actually this loop delay. It's actually every 30 seconds. This one is currently turned on to. You can see that we can also tell whether or not the settings have been synchronized down with the device. This one is, all settings have been synchronized. It is going every 30 seconds. If I wanted it to update every 5 to 10 seconds, well, let's just do 5 seconds. Let's see how that goes. So we'll see when this is. That is now synchronized, so we should see this one flashing much more often now. 1, 2, 3, 4, 5. There we go. So that's now going every 5 seconds. We'll get a little bit more data there, but that's okay. Let's go back to the summary tab for this one though, and we could see some of the information that I put in here and some of the information that was assigned as part of the Golioth console. We can see the usage here. We can see that I've been sending data 2 days ago and today, and some of that is over-the-air updates, which we'll show in a second here. Some of that is device logs, and some of that is our settings and all of that stuff is happening here. We can kind of see the status as well, see that this has been synchronizing, when it was created, when it was last updated as well, and what firmware it's running. In terms of the credentials, so if you went and downloaded this image, you went and put the binary onto your own Thingy91, you would go in here, you would add a new credential for your device that you've created on the Golioth console. Then you would program this into your device using a USB cable, talking to it over a UART, and you'd be able to put in your credentials so that when it connects over cellular to the cloud, it would then hit the Golioth backend, talk to the Golioth Cloud gateway, and present its credentials, PSK ID and PSK. That's like a username and password. Similarly, here we see the firmware. We'll come back to this actually. This is the individual view for this specific device right here. So we don't see any history here, but we will actually in a few minutes. We can also see that if we've got the LightDB state is the ad hoc digital twin that we've set up here. Really, LightDB state is a two-sided database, and what we're doing here is the two-sided database is basically the device can write to it, or the cloud can write to it, but we're actually saying the device is the master in this case, and it's the controller of its own destiny. It is actually reporting up to the cloud. When we want to send something down to this device, we've set up what we call an ad hoc digital twin, and so we have this desired and state. State is actually what the device is reporting back. Desired is if we want to go and change it, so we can go and change that now. So right now we could see that as I could turn on this to be refreshing every 3 seconds or so, and what we should be able to see is I can trigger individual readings here as well. So if I go and trigger a couple more readings, we should also see that it increments a little bit faster. But now if I go and actually go and edit in the desired, and I make this maybe 3000, and I hit save, we should see that it updates, and when it reports back to the cloud now, you see it's actually at 3000, and it's already started decrementing from that as well. So super useful. You probably couldn't see me hitting the save button. It's underneath it right there. So yes, so the save button is in the lower right there. But this is, again, it's just incrementing, decrementing, very simple counters up and down. Doesn't really do much more than that, but that's okay. You can make this kind of whatever you want it to be. You've seen people put their GPS coordinates in here, the maybe other state that they want to see of like a door, whether or not a door is locked, whether or not a LED is on. You can do all that stuff here, and it's really in order to showcase the state of the device as it exists, and then if you want to change it, you can do it with something like this desired capability here. Next up is LightDB Stream. So we're sending all the sensors data from this up to the cloud, and in this case we're doing this every 5 seconds. So let's go and expand this one. We should actually see if we turn on the live view here, which is even faster than that, every 3 seconds. So if I go and start triggering readings here, starting to really crank out some readings, and so instead of just every 5 seconds, we can see that those are all coming in as well. And we can see that I unfolded one of them, but it's kind of moving down the page as we go. We're reporting sensor, within the sensor path, we're reporting the accelerometer, the light, and the weather. And we're actually sending that up using the stream API. So we're basically doing a stream write from the Golioth device SDK. So within Zephyr and NCS on this device here, we're doing an asynchronous stream write, and then it's actually going into what's called our pipelines product. In this case, though, it's just recognizing that there is some data coming in that is JSON data on the general path, and then if it's JSON data coming in, we batch it up, we extract the timestamp, we inject the path, and then we send it to this LightDB Stream. We can see some of the other things we could send it to instead of LightDB Stream. So if we want to go external to the Golioth Cloud, we could also do that here. We could do webhooks, AWS SQS, really a whole range of different things here, and lots of stuff about that on the Golioth blog and our docs as well. You can see all the different places that you could send stuff to, including AI backends and similar fun new experimental ways to deal with the data you're sending out from your embedded devices. In our case, we're actually just directing it to our internal product, our time series product called LightDB Stream, and that's what you're seeing here. So each of these devices are hitting the Golioth Cloud gateway. Once it hits the gateway, it goes through a pipeline, and then, like I said, we're redirecting it to LightDB Stream so that we can view each one here. All of these devices are built on top of Zephyr, which has a really robust logging subsystem. So were I to plug in USB port here, or into the USB port, we would see much of the same data coming out of here onto the terminal. But in this case, we're just going to turn on the live logging, and we should see, because we've got a lot of, since this is on a 5-second setting here, we can see all of the debug messages that are coming through here. These are all, there's a couple retries that are warnings, I believe. That's if there's potentially, say my hand was in the way and it's blocking some of the antenna connection. It has retry mechanisms in there in order to go and talk to the tower again and make sure the data is actually getting up to the cloud. In terms of this data, you wouldn't want to go and extract this data from here. We are logging it in a debug manner, but we don't actually extract it from here. We're able to see it from the LightDB stream like I showed before. Settings we kind of started with here, but we could go and add an arbitrary number of settings here as well. And I'm just now realizing this may have been in the way. So you can see that these are synchronized. If I go and change them, they would be synchronized as well. Maybe I want to go and change how often or how fast the fade is happening here. You see that fade is a little bit faster there. So it's fading every 500 milliseconds, and then every time it's blinking, that's actually taking a reading and sending it up to the cloud. And finally, this is one that's hard for me to demo on calls, but I really like to do. We have a bunch of RPCs, or remote procedure calls. Each of these are, again, bespoke capabilities that we put into the Thingy91 and Thingy91X firmware that we deliver as a binary, and we can then trigger them from the cloud by entering the method here. I've already got a couple of them ready to go, and so in this case I'm just going to call that one and playing the Mario song that actually happens to be on board there. And that's fun. This one's actually a little bit more useful though. This is showing I'm calling the modem info library that's part of Nordic's firmware. It's just talking to the cell tower and saying, here's all the information, here's the towers I'm connected to, IP addresses on the local network, and things like that, which modem firmware I'm running. All very, very useful for troubleshooting. I can go and call this, rerun this at any time, and get an updated version of this and see, it's the same as before, but it's very, very useful there. In terms of the firmware updates, though, this is the thing that we don't usually get a chance to show in a lot of our videos and our calls with people. We love to show it off, though, is that we have a single firmware image for this device right now. Each of these, this is the binary image that you might have pulled from the GitHub repository, so we can go and see that there are many different versions here, 1.0 up through 1.4, and then we can go in and we can see how these are actually segmented. So I put two of these devices in the south and the east into the North Carolina cohort, and the west and the north into the California cohort, and I realize that's both are kind of in the south of the US at least, but needed to split them up somehow. So these are representing the California cohort, and these are representing the North Carolina cohort. If we go into the California cohort, we could see that these have been downgraded to version 1.3, but let's go and actually do a new deployment. We're going to go and update them to get the latest firmware version here. So we're going to say, all right, these get the 1.4 version. I'm going to do a deployment. It's got an auto-generated name based on the cohort and the date that's happening here. I'm going to go and start this deployment. There are no changes. Unchanged packages. I thought I did. There we go. Let's try that. There we go. Start deployment. All right, so now we're going to go and roll this out to these two devices here. And so what we can do is we can actually go into the devices and watch them. You see that it has now an outdated, one of them is actually already on, it's updating to 1.4, there we go. So we're going to look at the north one here. What we should be able to see is when we go into logs is that it's already downloading the blocks of new firmware coming from the cloud. There we go. And although this is like watching paint dry, not in terms of speed, but in terms of excitement, we see that it's a 371 kilobyte image that we're downloading to the device, and that even though we have maybe some resends and things like it, we're actually going to be sending data as we go along. So this one's on a 30-second. There we go. So it's actually still able to take readings, send them up to the cloud, even though it's downloading blocks in between. And even though it looks like it may be getting them kind of out of order, it's pushing them all together. And then once we get up to 371, we'll be able to see that happening here. What we can go back to in the cohort is looking at the event log here, and we should be able to see we have these deployments started, and this is actually a time kind of a calendar going across here. Now we're kind of zoomed all the way out, so it's on the right side here. But if you had a bunch of deployments happening within a week, you'd be able to see the history here. And if you had more than two devices, you'd see them kind of all the way down the page. So I'll just pause while these blocks are getting downloaded, and then we'll come back right before these things reboot. All right, looks like these should be about done here. If we go back and see, all right, so we are on the north one, and actually we see that the light has turned off because it's in a reboot cycle there. But if we go back a little bit in the history, we see it's been in downloaded state, downloading ready, updating ready, and we're starting into a reboot, so rebooting in a new image. I expect this west one should also start rebooting shortly as well. When it does come back up, it will connect back to the Golioth Cloud. Some of those messages won't be seen because they're done before it's connected back to the cloud. That one went off as well. And then we should also be able to see this happening. If we reload on the event log, we can see that as the state changes, that, there we go. So now this one has rebooted, and once it lights back up, it means it's connected back to the Golioth Cloud. There we go. And you saw that initial state as it has the kind of the default image, and then it gets the setting and it resynchronizes, and we see that that's red. I expect this one will start rebooting as well. If we reload this one more time, you see it's in ready. There we go, and that was the western one also going up there. So this one's successfully updated, this one's successfully updated, and so these are fully updated devices. They should now be on, if I go back to the firmware tab, I should see that these are both on version 1.4. There we go. And we see the individual for this north device as well. It also has its own individual event log, so you can see that, yes, this one did get 5 events to go and update, and then firmware uploaded as well. So we have successfully updated to the cohort for north and west, which we represented as California. North Carolina over here, which is south and east, those did not get an update, but I think they actually were already at version 1.4. But the idea is showing that, you know, some slice of your fleet could be updated separate from the other slice, and you're able to track it all from a high level. Now imagine this is now not 2 units, but actually 2,000 units, something like this view where you can see all of the devices and all of their states and all of whether or not they've been successfully updated. Super critical for seeing that sort of thing. Lots of other stuff inside the Golioth console that we have shown, will show, and are excited to show future stuff as well, including our location service and some of our new network capabilities that are coming out as part of our Bluetooth releases that we've been working on. We're really excited about all the things that you can do within the Golioth console. Like I mentioned at the beginning, I have the opportunity and the benefit to work every single day in the Golioth console, and so I really have normalized to it, and we hoping you are on that same path as well. So if you'd like to try it out, please go check out the Thingy91 or Thingy91X binary that you can download. Try without any code, any compilation. You can just go and try it out on your own fleet, your own deployment. You can light them up, you can make them sing with Mario, all that sort of thing. And you can then also go and download, all the firmware is open source, you can go and download it, modify it, target it at different devices. It is all built on top of NRF Connect SDK from Nordic, which is built on top of Zephyr. Those two things together make it so that you can target such a wide range of hardware, and it's really exciting to be able to see that sort of thing. So we're excited to see what you're going to build. We're excited to build more stuff here, including our reference designs and other capabilities and our new Bluetooth stuff that's coming out. If you have any questions, go over to the Golioth forum, and we'd love to talk to you over there, and we hope to see you soon in the Golioth console.